Okay, so this video is on the last packet of notes that I gave. It'll probably be split into two parts. This first section is the fundamental counting principle. It says if you can only choose one item out of m items and one item out of n items, the number of two item choices is going to be m times n. We just multiply those two numbers together. So a quick example, the restaurant has 6 appetizers and 14 main courses. How many two-course meals can be created? You can only choose one appetizer and one main course. That's why it's 2-course meals. So you just do 6 times 14, which is 84. So there are 84 two-course meals that can be created. If you have 30 t-shirts, 2 pairs of jeans, and 10 pairs of sneakers, how many outfits could you create? So we're assuming that you're only going to put on one t-shirt, one pair of jeans, and one pair of sneakers at a time. So if that's the case, 30 times 20 times 10 is 6,000 different outfits that could be created. So next time you say, or you think that you don't have anything to wear, it's probably not true. All right, car manufacturers are giving customers, yeah, I did a lot of shorthand there. Car manufacturers are giving customers the opportunity to customize a car with the following options: 9 possible colors, with or without AC, gas or electric, with or without onboard computer. How many different ways could a car be created? So the first thing you would do is create your categories. Notice we have colors, AC, power, and computer. And then how many choices do you have in each category? We have 9 possible colors. With or without, say, AC is 2. Gas or electric would be 2. And then with or without onboard computer, 2 choices. Once you've established that, then you multiply those numbers together, because remember, you only can choose one of each category. One color, one, with or without AC, you only choose one of those: gas or electric, and then with or without computer. Multiply those together, we have 72 different ways we can create a car. Here, you are taking a multiple choice test. It has 10 questions with 4 choices per question. There's only one correct answer per question. How many different ways could you answer all questions? So a lot of people make a mistake here and do 4 times 10, which would be 40, but that would be incorrect. So what we're doing here is we recognize each question is a category, and then under each question, we have 4 choices. So since we only choose one out of those 4, we can do 4 times itself 10 times. So that would be 4 to the 10th power, not 4 times 10, but 4 to the 10th power. And that will give us 1,048,576 different ways that we can actually answer this test. All right, telephone numbers in the US consist of a 3-digit area code followed by a 7-digit local number. The area code and local number cannot begin with 0 or 1. How many different phone numbers could be created? So we would establish each digit as a choice. So we got 3 digits area code and then a 7-digit local number. There are a total of 10 single digits. Counting 0, 1 through 9, and 0 would be 10 single digits. Those are the amount of choices that you have. So now, remember that the area code and the local number cannot begin with 1 or 0. So you're taking 2 of your choices away. So that's why we start your area code and local number with 8. We have 8 choices, cannot use 1 and 0. And then the rest of the digits, we have 10 digits that we can choose from. It doesn't matter. So you would do 8 times 10 times 10 times 8 times 10, 10, 10, 10, 10, 10. And that would be 6.4 billion. All right, so that's it for section 1. Section 2 starts off with permutations, an ordered arrangement of items in which the order matters, or no item is used more than once would be a permutation. So here, just a selection of comedians: Kevin Hart, Chris Rock, Will Ferrell, Cat Williams, Tiffany Haddish, Chris Tucker. Tiffany Haddish is the only female, and that's going to matter in a few. It says you are in charge of the lineup for the concert tonight. How many different ways could you arrange the comedians? So this is a form of permutation. So you have 6 slots, 1 through 6. So each box represents one of your slots. So just like before when we were dealing with telephone numbers and the cars, when you look at your slot, how many choices do you have for each slot? Well, in the first box, first slot, I have 6 comedians to choose from. When I go to the second slot, I only have 5 to choose from, because if I put 6 there, what I'm saying is if Kevin Hart goes first, that means Kevin Hart can also go second. So I don't want to put 6 for all of these boxes, because that will give everybody the opportunity to go all 6 times. So what happens is on the first slot, we have 6 comedians to choose from. Once you take one away, second slot, 5 comedians to choose from, 4, 3, 2, and 1. So, and then from there, multiply those together using the fundamental counting principle, and that would be 720. 720 different ways you could arrange the comedians. How many ways could you arrange the comedians if Hart goes first and Rock goes last? So if Hart goes first, that means you only have one choice for that first box. If Rock goes last, you only have one choice for that first box. So notice that's where we have stipulations on the first and last box, and we have the numbers 1 to represent each comedian that will be going, or each choice that we have for those boxes. Now when we get to box 2, it doesn't matter who goes there. But remember, 2 of comedians have already been used in box 1 and box 6. So that means we have 4 comedians left, and then we do our countdown, 4, 3, 2, 1. Multiply those numbers together, and we have 24. All right, factorial. Whenever you say exclamation point in mathematics, that's the factorial option. That means you will use that number and then count down by ones all the way to 1 and multiply those numbers together. 1 factorial is 1, 0 factorial is also equal to 1. So 4 factorial will be 4 times 3 times 2 times 1, which is 24. So you start off with the 4 and count down by ones all the way down to 1 and multiply those numbers together. So if I have 8 factorial over 5, now 5 factorial, now you can put these in the calculator and just calculate it out. But let's say if you were doing it by hand, this is the way you would look at simplifying. 8 factorial over 5 factorial, you can write out 8 factorial, 8 all the way down to 1. 5 factorial is 5 all the way down to 1. If you remember the simplification of your fractions, remember 5, 4, 3, 2, 1 cancels out because that's what's on top and the bottom. And that leaves you with 8 times 7 times 6, which is 336. So that's the long way of looking at that. Because let's say if I had 100 factorial over 98 factorial, what I don't want to do is have to write out 100 times 99 times 98 times 97 all the way down to 1. So the short way of looking at it is recognizing that this 5 factorial that's on bottom is inside of the 5 factorial, inside of the 8 factorial, excuse me. So I just go ahead and cancel out 5, 4, 3, 2, 1 in that 5 factorial. And what I'm left with is 876. Multiply those together, you get to 336. So going to the explanation or the example of 100 factorial over 98 factorial, I would just count my 100 all the way down to 98, because down bottom I have 98 factorial. That 98 factorial will cancel out with the top and bottom, and the top and bottom, leaving me with 100 times 99, which is 9900. So if I have 26 factorial over 21 factorial, I would take my 26 down to 21. The 21 factorial will cancel. Then 26 times 25, 24, 23, 22 will give me 7,893,600. So the formula for permutation, the permutation of n things taken r at a time, is n factorial or n minus r factorial. N is always your larger number because you're taking r things out of n. So if I had a group of 30 students, and I want to know how many different ways could I choose 5 out of the 30, the 30 would be n, the 5 would be r. So you're choosing 5 out of the 30. And how many different ways could you do that? So let's look at an example. You and 19 of your friends want to start a consulting firm. The group needs 3 officers, CEO, operating manager, and treasurer. How many ways could they be chosen? So in this type of example, this would be a permutation because we don't want to repeat either one of our offices. We don't want the CEO to be the operating manager or the treasurer or vice versa. So we got to be careful here. A lot of times when I do this example in class, a lot of people jump on that 19, but it's you and 19 of your friends, which means 20 is our n, our larger number. And we want to know how many different ways can I choose 3 out of the 20. Now there are calculators, scientific calculators normally have a permutation function, or if you Google permutation calculator, they ask you what is n, what is r, plug them in, they give you the number. But if you want to do it by hand, 20 factorial over 20 minus 3 factorial will be the formula. 20 minus 3, 17. You got to follow order of operations. And then you take that 20 down to 17. The 17 cancels, leaving you with 20 times 19 times 18, which is 6,840. Once again, you can just throw them in the calculator and get the 6,840. All right, so you are working for a television network, and your assignment is to set the schedule for the 7 p.m. to 10 p.m. time block. You have a choice of 13 shows, and each show is 30 minutes. How many different ways could you create a lineup? So we have 13 shows, and when you look at 7 p.m. to 10 p.m., that would mean 6 shows would have to fit in that time slot because they're 30 minutes apiece. So you get 6 30-minute shows. So that's where the 6 for R comes from. How many different ways can I choose 6 out of the 13? I have 6 shows that I can fit in this 3-hour time slot. 13 piece 6, throw it in your calculator, 1,235,520. Next section, before we go into part 2, combinations. We have permutations and we have combinations. Once again, combinations, you can do that on your laptop, website, scientific calculator. Same, it's very similar to permutation. It's just that with permutation, the order matters. Combination, the order does not matter. Here goes the formula for combinations. Very similar to the permutation formula. It's just that we have this R factorial out here that the permutation does not have. So if we have a 3-person committee, is needed to do a study. How many committees can be formed from the 8 people on the board? So 8 is our larger number. We want to know how many different ways can I choose 3 out of 8. So notice we don't have anything talking about order, first, second, third place, or anything like that. And we do not have anything talking about positions. So we just do 8C3, put that in the calculator, that'll give you 56. If you look at what I did here, if you want to do it by hand, of course you do order of operations first. 8 minus 3 will give you 5 factorial. You have 8 factorial over 5 factorial times 3 factorial. You cannot multiply these together and get 15 factorial. Those are separate applications. So that's 5 all the way down to 1, and there's 3 all the way down to 1. So the way I would do it, I would take my 8 and take it all the way down to 5 factorial, 8, 7, 6, 5. And that's going to cancel out with the 5 factorial down here. Then I would expand this 3 factorial, 3 times 2 times 1. And then 3 times 2 is 6. So that cancels out with the 6 right here. Leave me with just 8 times 7, which is 56. So once again, you can put it in a calculator, but if not, that's how you would do it by hand. All right. In poker, a person is dealt 5 cards on a standard 52-card deck. How many different ways could a 5-card hand be created? So 52 is a number of cards that we have. Note the total number of cards. R is 5. How many different ways can we choose 5 out of the 52? So there's 52C5. Put that in the calculator, we get 2,598,960. All right, one more for this section. Senate consists of 60 Democrats and 40 Republicans. How many 5-person committees can be formed if there must be 3 Democrats and 2 Republicans? So those 3 Democrats have to come out of the 60 Democrats. The 2 Republicans in the committee has to come out of the 40 Republicans in the Senate. So you can't do 40 plus 60, which is 100, and do 3 coming out of 100. No, the 3 cannot come out of the 40 Republicans. Those 3 Democrats cannot come out of the 40 Republicans. They can only come out of the 60 Democrats. So we have 2 different categories, 2 different calculations. 60C3 is our first calculation, which gives me 34,220. And then 40C2 gives me 780. Once I have those 2 numbers, once again, the 3 came out of the 60, the 2 came out of the 40. Multiply those 2 numbers together, and we get 26,691,600. Let me know if you have any questions on that first part.